Thanks everyone for coming. I'm going to be talking about cookies, but first a couple cookie-related jokes. What's Milk's favorite band? Oreo Speedwagon. What do you say when no one laughs at your cookie joke? Dough, sorry, that was half-baked. Okay, so we're going to be talking about why someone would want to steal HTTP cookies off of your client. And we're going to talk about how that could happen and what you can do to protect yourself. People stealing cookies off the wire is kind of a well-known attack over plain HTTP. But I'm going to talk about how they're stored on HTTP clients like your computer and how those can be stolen. Just before we get going, the opinions in this presentation are mine and not my employer's, and the security issues I discuss are not vulnerabilities in particular websites. You'll see some logos from screenshots. I'm not going after particular websites. This is sort of a systemic issue that I see. So don't get too excited and live tweet, oh my god, Google got hacked. That's not what's happening here. Okay, so what is an HTTP cookie? Cookies are name value pairs that are transmitted as HTTP headers, both in requests and responses. A typical use case, and the one I'm going to focus on for pretty much the whole talk, is a client sends a username and password. So you're in your browser, you type your username and password, you send it to a server in a login form. Server sends back a cookie that's then your authentication token going forward, so you don't have to constantly re-enter your password. So that's a very common use of cookies, and that's the one I'm going to focus on. So for those of you who have never seen cookies before, can we see that? Yeah, good. Okay. They have some attributes besides just name and value. So they're associated with a domain. This is a fresh request to twitter.com from an incognito session. This is Chromium's developer toolbar. And their namespace, I guess, with a path. So if it only applies to part of a site, the browser will only send the cookie for a certain path within a website. They expire. A session cookie, the term session is overloaded. So a session cookie is both a cookie you use as an authentication token and a cookie that expires when you log out or when you close your browser. So here, the expiration time session means when you close your browser, the cookie's gone. It expires when you close your session. A lot of them just have dates sometime in the future. This just says the size. And HTTP-only cookies, there are two extra flags. HTTP-only cookies cannot be seen from client-side scripting like JavaScript. So this mitigates some cross-site scripting attacks where normally someone could read your cookie from JavaScript and send it to some bad server somewhere. HTTP-only cookies can't be accessed from JavaScript. It's only part of the initial HTTP request. And secure cookies are only sent over HTTPS connections, not HTTP. So if you accidentally type in http://gmail.com, you're going to connect there and get redirected to the HTTPS version, but your cookie won't get sent if it's marked as secure. So it's another security feature. So everyone knows it's bad if someone takes over your machine, but I'm going to sort of deep dive into that a little bit and some things that I haven't heard other people talk about too much. So any process that runs your user with a sort of default configured system can read your private keys, which hopefully have passwords on them for that reason. Some software stores passwords as plain text. So like IAM clients and FTP clients will often just, when you say, yes, save my password for Pigeon or wherever your FTP client is, that's going to be in a text file somewhere, an XML file, and it's just your password that you typed in. It'll send that to the server every time you authenticate. So that's on your hard drive somewhere. And web browser cookies are generally stored as plain text, but they're always readable as your user. I gave a 5-minute talk at another conference on this called User Readable Data and Multiple Personality Disorder to sort of illustrate the theme. And the whole idea here is data exfiltration attacks. So someone gets on your machine, they see data they want, they take it to another server somewhere, and then they're done. They don't need to escalate privileges, and they don't need to persist. So this is kind of the crux of my talk. So I believe cookies can be more valuable than passwords some of the time. I'll go into a little more detail of that in the next couple slides. But usually people think of, oh, I got to protect my passwords. A cookie is, what's a cookie? Especially to an attacker. But I think they're pretty valuable. So counterpoints, cookies expire, whereas passwords sometimes expire, but for web applications they often don't. A lot of sites will make you re-enter your password before you do something special, like change your password. You'll have to re-enter the initial one, or before you add an SSH key on GitHub, you'll have to re-enter your password. So in that sense, passwords are more important than cookies. You can't do everything with a cookie, but you can do a lot. So how many people use Gmail but do not have two-factor authentication enabled? Raise your hands. How many of your passwords start with the letter A? Just kidding. Kind of. So two-factor authentication, for people who aren't familiar, is there's a password, which is one factor, something you know, and then there's a second factor, which is something you have, like a phone. So the idea is that if a bad guy's going to take over your account, they need both your password, something you know, and something you have. So what will happen is you enter your username and password, and then you'll get a text to your phone after you've authenticated successfully, and then you'll have to enter a code that was sent to your phone either in text or a little app into your web browser to verify that this is the account, the person who owns the account. So if you have a cookie, you actually bypass this because it's an authentication token, you're already authenticated. So on the last slide I said, if someone steals your Gmail cookie, they bypass two-factor. So that's kind of interesting. Usually if you just steal a password, you wouldn't be able to get in, but if you steal the cookie, you can. And somewhat similarly for Facebook, if you log in authenticate from a new location, new IP address, you'll get a little email to your account email, and we'll say, hey, someone new logged in, is this you? But if you have an authentication or a session cookie and you log in with the session cookie, you just make it as part of your HTTP request, which I'll show later. You don't get this email triggered. So in that sense, again, the cookie is more valuable to an attacker than username and password. So we're going to take another little cookie joke break. Everyone be ready, prepare yourselves, brace yourselves. What do cookies have in common with stoners? Both are freshly baked. Okay, so we're going to talk about the way that browsers store cookies, because the idea is if someone takes over your machine or just is on it for a temporary period of time, how would they read your cookies? What's involved in doing that? So most browsers store cookies as plain text, and the HTTP only and secure flags I talked about earlier are only inside of browsers. So it's up to the HTTP client to enforce them to protect you. So malware does not need to enforce them. Malware doesn't need to respect them. The cookies are all stored in the same place. So your secure cookies are stored alongside your not secure cookies. Firefox is one of the popular browsers I'm going to talk about. I'm talking about, I think, 5. It stores cookies in SQLite database. So that means you can read them using the SQLite 3 command line tool. Python has SQLite support baked in. You can link against SQLite libraries. So example of SQLite connection. We, on Mac, open the database just by passing the path to the SQLite 3 command line tool. And can you read this? Yeah, cool. And schema just shows what the table is, how the table is created. You can see that name and value are both text columns on the end of the second column and end of the second row, beginning of the third row on the second command. And all it takes to read the cookies out of the Firefox cookie database is select value from most cookies where name equals GX, where GX is the Gmail cookie. And it would be pretty ironic if my dummy account got taken over because I posted my cookie here. But it's a dummy account, so I don't really care. And there's also a second SID cookie that Google Accounts uses. So I'm not too worried, but I'd love if someone took over the account and sent itself a bunch of emails. So if you get bored, you could try doing that. But I think you need another cookie. IE is interesting. So it stores cookies as text files, not in a database. The folder where the cookies are stored depends on IE version. And file names are random. So in order to actually get the value you're looking for, like the GX cookie for Gmail, you would need to iterate through all the files. So you're programmatically on the machine, you run a script, loop through all the files in this directory that have random names, which we'll see here, and pick out the one you want. So I'm reading a bunch of cookies, and one of them has GX in the place where Internet Explorer puts the name. Okay, that's the one I want. But you can't just do an index search. You have to actually loop through them all, as far as I know. I blacked it out. It's my Google Analytics cookie. It's not a big deal, but I'm paranoid because it's DEF CON. Yes?
In that case, how does a company know which cookies are theirs? So let's say I'm shopping at Amazon, I go back on, the day after, of course, they've got cookies there. How does Amazon know which cookie you like, or in particular, how does IE know which cookie is associated with Amazon?
So only the web browser says, you see on the Twitter slide, this is an Amazon.com cookie, this is a Twitter cookie. So the only cookies that get sent to the site are ones that are marked by the client as belonging to that site. Does that make sense? The question was, how do you know how are particular cookies sent to the right site? Okay, so Opera and Safari use custom binary formats to store their cookies, but they're freely available software tools for parsing them, so it's not, hard to read. Safari, the file is called cookies.binary cookies, in case you weren't sure there were cookies in there. And Opera, it's called cookies4.dat. So just a quick example of these free software tools, which I didn't write, but one was a GitHub gist and one was just a blog post. Python script to read cookies and find the Yahoo ones. Not really that interesting compared to anything else. Opera, same thing. They just put a bunch of debug info in when they're parsing it. I didn't clean it up because it's just a demo. Okay, Chromium is by far the most interesting browser for cookies. I'm going to focus on it the most. So Chromium in recent versions encrypts cookies. It got a bunch of press in January for doing that, so it's been there for a little while. It was in the dev version for a few months before it made it into the mainline Chrome. And when I say Chromium, I'm talking about the open source version of the Chrome browser. They're pretty much equivalent. Chrome just has Google branding. So it stores cookies in an SQLite database, and before, just like Firefox, there was a name and a value text column, but now there's an encrypted value blob column, which means binary data can go in there. And it'll still use the text column, the value, but it'll look in the encrypted value field to see if there's been an encrypted cookie set. And I'll show more about that. So on Linux, there's no single standard keychain. KDE, GNOME, the different desktop environments all have their own keychain. So there's no Linux keychain. Keychain being a place where you type in your password and says, hey, you want to save this in a secure location, encrypted. So there's one master password for all your system passwords for your user. So Linux doesn't have a centralized one. So on Chromium, what they did for Linux encryption of cookies was they used AES, which is symmetric key encryption. Oops. And they used a hard-coded key and salt in the source code. So what that means is that if you encrypt your cookies on one machine, they can be decrypted on any machine because you can just read the source code, get that key and salt, and then decrypt cookies. So I say it's obfuscated, not encrypted. And there are comments in their source code about this. They just haven't fixed it yet. So reading, what I did was I linked against the Chromium libraries. So you can just call code to decrypt, undo the crypto that they're doing. But I decided I would basically just reuse their code because I'm lazy. And the way that works is there's a binary blob, which looks like garbage here. But when you call the code to decrypt it, it spits out the same DQAA prefixed cookie that was on Firefox. It's GX cookie again, so you don't have SID yet, so you can't take over my account, I don't think. So what this means is that if you, on the black shell, which is one computer, read the cookie out of the database, you're some malicious actor, then you base64 encode it, send it over the wire, or in my case, just copy paste it into a text file because it's in a VM. You can read it on another computer and decrypt it on another computer. So it's not really encrypted. Windows is encrypted, so it uses the crypt protect data function to encrypt cookies for Chromium on Windows. And that's a Windows crypto API. So it's part of the sort of system library, it's standard stuff for Windows. And it uses login credentials as part of the encryption. So if you just have access to someone's computer powered off, you need their login credentials to decrypt the cookies. Whereas on Linux, that's not the case. You can just encrypt them on any machine. So crypt protect unprotect data is sort of the twin function of crypt protect data, and you must call it as the same user that encrypted on the same machine. Chromium on Mac is perhaps state of the art of cookie storage in browsers. So they store a system, in the system keychain, they store an encryption key. And if there isn't one there at the beginning, they just generate a random one and put it in there. And then use AES to encrypt decrypt with that protected secret. And one thing to note is that if you have an unsigned app and you try and access the keychain, there'll be a little pop-up to the user. So if you just got some random malware running on your computer and tries to access your keychain, you'll get notified. And it will look like that. So in that sense, it's harder for an app that you don't trust to read cookies out of your, or read secrets out of your keychain in general. It's a Mac security feature, which is cool. Okay, so in summary, Chromium encrypts cookies on Windows and Mac. It obfuscates them on Linux, and other popular browsers store the cookies as plain text, Firefox. Opera and Safari store them as plain text in a binary file format, but they're just there to read. Okay. So we're going to talk about some attack vectors. I tried to come up with more cookie jokes, but they were all too crummy. So the first one, which I alluded to earlier, is physical access, which is someone gets access to your powered off machine. You don't have disk encryption on. They turn it on, and they read your cookies. Chromium actually protects you from this on Windows and Mac due to the encryption. So that's pretty cool. That's novel. That did not exist until 8 months ago. So that's pretty cool. Social engineering is another attack vector. So if someone gets you to run an Excel or Word document that has a macro in it, they can run Visual Basic for Applications code on your computer. And then they can call code or download code from the internet to read the cookies or just read the cookies and then ship them somewhere else. And I have a demo of this later, or slides of a demo. So again, you don't need to install anything. You don't need to persist. It's a data exfiltration attack if someone's attacking you, where they just get on your machine, get the cookie, leave, and then reuse it before it expires. That's kind of scary. Malware, similar to social engineering, kind of overlap. If someone drops and runs an executable, there's a hole with Metasploit. You get code execution on the machine. Again, it can be any process that runs as your user can read your cookies. And the idea from an attacker perspective would be, I want to send the cookies over HTTPS, or I guess just plain HTTP, to a server somewhere and then use them myself. Does that make sense? Cool. Okay, so here's a proof of concept I did of that idea. So what I did was I wrote some code to read cookies off of the client in various situations. So for Chromium on Windows, for Chromium on Linux, and for Firefox. And I ran that in other machines. So one's a VM, or these are both VMs. The top one, the Google one, is a Windows VM, and the other one's a Linux VM. So I ran the malicious code that I wrote for myself, and then sent the cookies to my listening server, which is a cookie capturing server. And then when I, in the admin interface, click Use Cookies in Browser and press the Go button, it creates a temporary profile with cookies in it in Chromium and logs in to the accounts from another setup. So you're able to use the cookies to log in. It's kind of semi-automated, bypassing two-factor, bypassing the new login location notification email. At this point, I think I milked all the cookie jokes for all they're worth. So disk encryption prevents against physical access. That's kind of a good idea from a security perspective in general. But with data exfiltration or just someone reading your computer that you don't want to, and in this particular situation, it's good if you have disk encryption that will protect you from physical access. Application firewalls are an interesting tool. So the idea is you can block or allow traffic based on server port pairs per application. So you can say, this application can access this server and this port. So if another application tries to do the same thing, you'll get a pop-up. So example, Chromium can access Google on port 443 for HTTPS. Little Snitch is a popular way of doing this for Mac. It's a commercial product. Windows, I think NetLimiter is one that does the same thing. Linux is an interesting case. There aren't any stable, currently maintained application firewalls for Linux that I know of. I'd love to hear of them if you know. There are a couple different products that are supposed to do it open source, but there's a currently maintained one that's not stable, and there's stable ones that are not currently maintained. So that'd be great to see going forward. Little Snitch, here's an example of it just to illustrate. When I try and read Reddit from HTTP request from the command line, it says, hey, your command line is trying to access Reddit. Do you want to allow that permanently or just once? SU Linux is another thing that helps with this kind of defense against this kind of attack. So it segments your applications from each other. So before I was saying, if a process runs as your user, it can read all of your files. Well, SU Linux and other tools like it have sort of extra access control that you can apply on top of normal Unix access control. So you can say, I own these two files, but only one process can access this one, and only another process can access that one. So if a third process spins up, it's just malware, it's random, it won't be able to access either, even if they're all owned as my user. So one idea I had that I don't know if will get implemented for cookies is a master password for cookies. So the idea is your cookies are stored encrypted on your hard drive, and it's kind of two-factor idea where you need to enter a password at the beginning of your browser session to decrypt your cookies before you can access them. It's not too inconvenient because you only have to enter the password once per session. And Firefox actually does this to protect passwords. Chromium doesn't. They made an intentional decision not to. So here's what it looks like for Firefox's password manager, and you can imagine something similar for cookies. So the idea is that the passwords are all stored on your hard drive. They can be read by any process that runs your user, but they're encrypted unless you enter this password. And then one interesting defense is tying a session cookie to the login IP. So when someone authenticates initially, the very first time, you say, okay, they authenticated from this IP address. And then if they try and log in from a different IP address later with that cookie, it'll reject them and make them re-authenticate. It'll only work with that IP address. cPanel, which is a web hosting configuration tool, actually does this optionally. There are a bunch of people who are really confused on their forums because they log in from one place, they go somewhere else, and their authentication, they need to re-log in every time they go to the coffee shop and come back home. So it's a trade-off of security versus convenience. And I think that's a little too extreme. But what you can do, which Gmail does, is you can say, hey, where have I logged in from recently? So I've logged in from 5 countries this month. I haven't been traveling. Should probably do something about that. Okay, I think I blew through these pretty fast. But cookies should be handled with care, and client-side cookie security is not a solved problem. It's something that I think needs more thought going forward. And that is how the cookie crumbles. Any questions? Yeah. So the question is, how do you protect the hard drive? With cookies or in general? Okay, so having an encrypted hard drive is a form of protection. How does that work is the question. And the way that works is if someone accesses your computer, before they can mount your hard drive, before they can read the files on your hard drive, they need to enter a secret, a password, a key. And if that password's strong, they have to guess that key before they can read the files on your computer. So in that sense, disk encryption prevents someone from accessing your computer and just opening it up and reading your files. So if your disk isn't encrypted, someone can just put in a Linux live CD, and they'll be able to read all the files on your hard drive. Correct. So if they have physical access, disk encryption helps. If they're accessing you remotely, if they're hitting you remotely, disk encryption doesn't help because everything's in memory anyway. Or, yeah? So the question is the encryption on Chromium enough for this kind of attack? Mathematically it is, so it's good encryption, but on Linux, they use a hard-coded key. So in that sense, the encryption doesn't matter because you can just reverse it trivially. On the other two, it should be good, I think. Yeah? So the question is, why didn't the encryption prevent the cookie from being exfiltrated?
Well, not exfiltrated, but it allows you to use the same cookie on a different system for a different user, right?
So the reason that the cookie was able to be exfiltrated is it's decrypted on the client where it lives. So you call code to read the cookie and then decrypt it, and then you send it somewhere. No, it's meant, actually I emailed the Chromium security team about why it's different on Linux, and they said that The main reason was they wanted to protect people on Windows who didn't have full disk encryption. That was their main intention. So it's by design in some sense. So the question, does CSRF protection help? I'm not sure I understand how. Okay, so the question is, does CSRF protection, which invalidates sessions if the nonce isn't sent, does that protect people from this kind of attack? I would say no, because once you get the cookie into the browser, like in the little proof of concept, then you're just that user. Like you're in the browser as that user. So it'll do all the normal CSRF stuff. It'll read the tokens and send them along with the requests. I'm sorry, could you repeat that?
Could you, as a site, when you're writing cookies to the client side, can you, for instance, give the ability for another domain to access the cookie? For instance, I'm logging into Google, I want someone from Yahoo to be able to read. Weird example, but yeah. And could someone take advantage of that?
So the question is, could you have cookies that belong to multiple sites? I think the browser, the way cookies are stored, probably doesn't support that. I think domain is just a column right now. It's just one thing. And I think the security implications of that are kind of scary. If you sent, well, it would be ignored by the site unless there was some collaboration between the two sites on the back end. Like if I have Yahoo and Google cookie that goes to both of them, if it's from Yahoo, Google would need to know about that. Would need to have something in its session store on the server saying, okay, this is a valid cookie. So in that sense, it wouldn't really get you much more than having just two separate cookies. Anyone else? Yes? Does client-side JavaScript have access to non-HTTP only cookies? I think that's the idea. I think that's what HTTP only means. For that site. Not just for like any site in the world. Someone else over here?
What's your best suggestion for destruction of cookies as soon as the session is over or closed or whatever?
Right. So if you're really paranoid, what you do is you just don't save cookies. You have everything be a session cookie, and then it expires when you close your browser, and then you're happy. Again, that's annoying because you have to re-authenticate all the time. I think application firewalls are a good choice for if you're like, no one's really doing this as far as I know, this kind of attack. But if it started happening, application firewalls would be a decent choice. Something like SE Linux to segment applications from each other would be a good choice. But I think application firewalls take a performance hit because you have to inspect packets as they go out to say, hey, does this meet all the rules? So that'll slow you down. But I think encrypting the cookies, I think the master password is a decent idea. I haven't seen any discussion of that. I know, like I said earlier, Chrome devs said this is not a good idea. It's not really extra security. If someone's on your machine, you're in trouble anyway. We're not going to give you the false illusion that if someone's on your machine, you're going to be okay because you have a cookie or a password, a master password for your passwords. So that was why they actually didn't implement it in Chrome, as far as I know. So, but I think a master password for cookies is decent.
Just for good information for the crowd, what can we do as web designers to help the client be as secure as possible related to cookies?
So the question is, how can you help the client be as secure as possible with cookies as developers?
Yeah, developing websites.
Mm-hmm. So setting cookies as secure and setting them as HTTP only if you don't need the JavaScript to be able to read it. Like all session cookies should not be accessible from JavaScript. That's the thing that everyone should be doing all the time. HTTPS versus HTTP. First, if you have any login or any sensitive information, you definitely want to be using HTTPS because there are a couple older attacks where if you're sniffing Wi-Fi or just on the network with somebody and you see an HTTP cookie, or a cookie going over HTTP, you can sniff that cookie and then steal it that way. That's fairly well known. So using HTTPS and then setting your cookies as HTTP only and secure, HTTP only when possible and secure always if you're using HTTPS, I'd recommend are sort of the fundamental things you can do. Everything else is more at the like browser implementer level. So I thought about that. The question is, has someone thought about going down a layer to the MAC address rather than tying the session cookie to the IP, tying it to the MAC address? And I think there are two problems. One is if you're just a web server listening, and the cookies are mostly set at the web server level, so you don't want to be trying to like read the packets as they come in for MAC addresses. But the more fundamental thing is someone on your computer could sniff the MAC address and then spoof it when they're trying to log in as you from some other machine. So that they can just enter commands to read the MAC address that you're using right now, possibly try it with multiple interfaces if your computer has like Ethernet and Wi-Fi, and then spoof it later. So I don't even think that would protect you.
Do session cookies, when they apply, when we talked about the web developer before his question, kind of a follow-on. If I'm a hacker and I go in and utilize the cookie that I've stolen, would it be able to be identified that I now have 2 sessions running? In other words, could there be something done at that level that would say, well, there's something 2 sessions, or is that just kind of common still?
So the question is, if a cookie is used multiple times, is there a way for the server to know it's 2 different sessions? And I think the IP way is one, unless you're on the same network as them, and then it just looks exactly the same IP, and then your host. But right now, I think most sites, it just looks like the same session. It looks like one user. Because what happens is you log in, you get the cookie back, you log in again, you get a different cookie back. So if you use the same cookie, it just assumes it's the same entry in the session store, usually, in the database, I think. Anyone else?
Same scenario, if you're taking someone else's cookie, could you set the expiry date further down the track so you have a longer period of time to utilize it?
The question is, can cookies from the client extend their expiration date? And the answer is usually it's set on the server. You wouldn't want people to be able to steal cookies and then extend them like that. I haven't seen any applications that are like, when you log in, do you want to stay logged in for 2 weeks, 4 weeks, or a year? I haven't seen that. Yeah. Okay. Are we done? Thanks, guys.